So in this lesson, we are going to talk about inscribed angles. And here is the visual description of inscribed angle and then the relationship between inscribed angles in a circle. First of all, let's define few things. We have a circle. There's a center of the circle. This is C, center. And these lines that you can see, so let's call this A, this vertex right there, and B, and then C, and then D. And we're not going to label that intersection between AC and BD just for the simplicity's sake. Now, AD, any of the line that you see that goes from one side or from the circumference of the circle to another side or another part of the circle, AD, we call that a chord in a circle. Okay, so any straight line that connects two parts of circumference of the circle, we call that AD. There's another one, BD, and the notation, the line on top, that actually means is a chord. We don't have to write chord anymore. Okay, and the next one is, you can say AC and BC. Okay, so they're all chords for a circle in this specific circle. Notice that when A and B and C and D, notice that they're all vertices and there is an angle that is being created by the chords that is being created from that vertex. So AD and AC, there are two chords. They are basically connecting at point A, and they're going to create this angle right there. And the angle basically created is on the circumference of the circle between the two chords. This angle, it is called inscribed angle in a circle. And can we name other ones? Sure, we can. Here we go. Now, CBD, that's another one. So that's another inscribed angle. And I'm going to call it INS angle. Can we come up with another one? Of course we can. This one, D, and also C, BDA and BCA. Both of these are also inscribed angles. Okay, now that we have the definitions set up, now we need to look at the relationship between inscribed angles where they share a chord and an arc. One more thing before we forget, so let's talk about an arc. What is an arc in a circle? So what is an arc in a circle? And I started explaining that. Let me go to a new picture. So an arc is any segment of the circumference of the circle that has been basically cut out by 2 points. So let's call this C and D, and this part of the circle, this portion of the circumference of the circle, is called an arc. Okay, and there's another one, we can use this one, that's another arc. Let's call that AB. And the way we say, we actually write it in geometry, we say AB and then we put an arc like that on top of it. It's like a notation. So CD, you put an arc like that on top. Okay, little line, it's curved line. All right, so that's the definition. So we have the arc, we have the chords, we have the inscribed angles. All right, now we can talk about the relationship, and it's very easy. And the relationship is this, that if you have two inscribed angles, so let's look at the two inscribed angles, B and C. So right here and right there. When these two inscribed angles, they share the same arc, and they are Notice that this angle opposite, the arc opposite to that angle is CD, arc CD, and the angle B, which is right here, has the same and opposite same arc CD. If you have a situation like that, that two inscribed angles, they share the same arc or the same chord, you could actually create a chord here. And the chord that you can create, let me create it. This could be a straight chord right there. Now I'm doing a freestyle. That could be the same thing. You have a chord CD. The same thing. If that's the case, then the inscribed angle A is equal to inscribed angle B. And that is true all the time. The only part that is not true is that the inscribed angle, they share a chord that is being shared opposite of each other. And I'm going to give you an example on that in a second. So the key is, if you have the same arc opposite the inscribed angles, okay, both, they're the same, the chord and the arc both are basically have to be the same for the opposite inscribed angles to be equal to each other. But mostly you're going to focus on the arc, okay? So the chord doesn't count, but the arc does. And if you stick with that, then it's always true. Now, let me give you an example. If you have a situation like this, you have an inscribed angle which is C, which is, you have an inscribed angle that is D, but notice that the arc for D is this, the big one. And the arc for C, right? So this is the arc. This is the arc opposite of angle D. And the arc for C is actually that. They're not the same arc. Let's notice this. And you can't say that's because of they are sharing the same chord, because they are opposite same chord, right? Not the arc, but the chord, which is right here. This is the chord that I drew on using dotted line. So because of their sharing it, that you can't just say, oh, sharing the same chord, therefore they're equal to each other. No, because their arcs are different measure. We don't know the length of them. We don't know if they're the same or not. So in this case, these two inscribed angles are not the same. So whenever you have an opposite setup like this, they are not the same. They are related to each other. We're going to talk about that in another lesson. Okay, that's about it.